Okay, so moving on to today's lesson, I want to talk about the objectives. If you see the objectives portion in your package, there are some blanks. This lets us know what it is we're actually learning. So you'll go ahead and you'll fill in the blanks with me. It says evaluate expressions containing, and here's what we're doing. We're doing expressions that contain 0, so you can fill in 0, and negative exponents. This is when you have an exponent of 0 or an exponent that is a negative number. For an example, you could have 2 to the 0, that's a 0 exponent. You could have 2 to the negative 3 power. That's a negative exponent. What happens when we see this case is what we are learning. We're going to also learn how to simplify expressions. That's like we just simplified an expression in the warm-up by substituting and then doing all the math work out for it. But how do we simplify those expressions if it has a 0 or a negative exponent? Okay? So up until now, you've seen some very easy exponents: 2 to the 3rd, 4 to the 2nd, 5 to the 7th. But what happens when it's 5 to the negative 7? How do I solve that? That's what we'll be learning this week. I'm moving forward on to the next slide. This slide here talks about what I just mentioned. So we have seen the positive exponents. For an example, 3 to the 2nd power uses 3 as a factor 2 times. So it's 3 times 3 is 9. This is normal and what we already know how to do. But what does it mean for an exponent to be negative or a 0 is this week's learning. What I want to show you is a pattern that exists. So here, if we were at 5 to the 5th power, that would be 5 times 5 times 5 times 5 times 5, which would give you the value 3,125. But every time you go down a power, you notice here, this is to the 4th power, it went down a power. To the 3rd power, it went down a power. It gets divided by 5 each time. However, when we get to 5 to the 1st power, or just 5 one time, is 5. Anything to the 1 power is itself, just like anything multiplied by 1 is itself. We run into a situation when we come here and we continue the pattern divided by 5. Well, what is 5 divided by 5?
1. 0. Oh, shit.
1. So 5 to the 0 power is?
0. No, 1.
1. You ready? If I continued and this divided by 5 pattern, so that went to there, that went to there. What if I divide by 5? What is 1 divided by 5 in a fraction? It looks like this. 1 over 5. 1 divided by 5. So actually, watch this. 1 divided by 5. Now, 1 over 5 divided by 5. If we divide by 5 again. Now, what is it?
1 over 10.
Not 10, but I like where you were thinking because it's so close. So when you divide, can we divide 1 over 5 divided by 5 looks like this. We make that a fraction. What is it?
0.5.
Not 0.5, but can we divide fractions? We do not divide fractions. We have to multiply by the reciprocal. Yes.
Can you change it, flip it? Is that it?
Yes, keep, change, flip. Okay, so then we end up with 1 over 5 times, instead of 5 over 1, we flip it to 1 over 5. 1 times 1 is 1. 5 times 5 is 25. Okay? 5 times 5 is 25. So if you were really having a problem with remembering the rule that I'm going to show you soon, that's a way you could figure out. But if you notice the pattern, every time you drop one power, even dropping down to the negative, you continue to divide by 5. Okay? So here's what it looks like as a rule. When the exponent increases by 1, the value is divided by 5. Continue the pattern. We saw here that when we had 5 to the 0 power, it was 5 divided by 5, or 1. Anything raised to the 0 power equals 1. That's something you need to know today. Anything raised to the 0 power equals 1. So that should be a give me on any test. If it's raised to 0, the answer is 1. However, the tricky part is here. If it's raised to a negative power, here's the fastest way. As soon as you see a negative, you know you're going to put a fraction bar with a 1 over it. Whatever your base is, goes on the bottom with a positive exponent this time. You flip the exponent, instead of negative, you make it positive. And then, so 5 to the first power is just 5, so your answer is 1 over 5. But here, if you have 5 to the negative 2 power, this is how we got 25 the easy way. 5 to the negative 2. As soon as I see a negative exponent, I make a fraction bar. 1 over the base, which was 5,
25.
the exponent, positive. So instead of negative 2, I put a 2. But now I have to go ahead and do the work. 5 squared means 5 times 5, which is 25. So that's how we get 1 over 25. Using this method, you can solve for any. What if I told you it was 5 to the negative 3rd power? I would immediately, because I see the negative power, make a fraction bar, do 1 over, still 5, but instead of to the negative 3rd, it'll just be to the positive 3rd. That's the learning. That means 1 over 5 to the 3rd is 5 times 5 times 5. Well, 5 times 5 is 25, and 25 times 5 is 125. 1 over 125 would be your answer for 5 to the negative 3rd power. I hope you caught that, because that's the major part of the learning today. Now, how would you write that in words? 0 exponent is any non-zero number raised to the 0 power is 1. Fill in that circle there, or check mark, if you heard me and did that part.
I heard you. I did that part.
So what it looks like is, if, let's say, you had 3 raised to the 0, it would be 1. What if you had a negative 16 raised to the 0? It would be?
Is it 1?
1. Anything raised to 0 is 1. How it looks like in algebra terms, it says this. So x raised to the 0 power is 1. When we see this thing about non-zero number, it means also saying that x is not equal to 0. So when you see that x is not equal to 0, as long as x is not 0, whatever is raised to the 0 power is 1. Now for a negative exponent is, again, a non-zero number. A non-zero number is a number that is not 0. Non-zero. It's not 0. It's any other number. Okay? It's raised to a negative exponent is equal to 1 divided by that number with the positive exponent. If you heard me, fill in that circle and make a little check mark for credit. So here's what it looks like. If I had 3 to the negative 2, Well, it's 1 divided by, you're going to use this whole term again, but take out the negative. So 3/2. Just take the negative out. 1 over the whole problem without the negative, which actually would be 3 squared is 3 times 3, which would be equal to 1/9. So 3 to the negative 2 is 1/9. Another example of that would be here, 2 to the negative 4th. What would I do? Immediately I see the negative power, 1 over 2 to the 4th. Just the whole thing, but take out the negative. But you might want to solve now. So 2 times 2 times 2 times 2 is how you do 2 to the 4th. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So it's 1/16 is my answer for that. How it looks in algebra is very funny looking. So we say if we have any number raised to the nth power. The nth power could be 6th power. Could be 8th power. But here we're talking about negative. So any number raised to the negative power. So any number x raised to the negative nth power. Nth power is very commonly used in algebra, using the n for any power. Equals exactly what we said. 1 over the whole thing without the negative. X to the n power. This whole thing without the negative. Okay? So this is how we do 0 exponents equal 1. Negative exponents equals 1 over the same base of exponent, but without the negative. Okay? So let's see how that looks. So an example, 1 cup is 2 to the negative 4th power gallons. Simplify this expression. All we do, 2 to the negative 4, immediately I see that negative 4, I put 1 over 2 to the 4th. I took out the negative. Then I just solved it. 2 times 2 times 2 is 16. So it comes out to 2 to the negative 4th gallons is equal to 1/16 gallons. Okay? Next part. A sandfly may have a wingspan up to 5 to the negative 3rd meters. Simplify this expression. What they did, they saw 5 to the negative 3, immediately said, oh, negative exponent, I must do 1 over. 1 over 5 to the 3rd, I took out the negative sign. And then I just solved it. 5 times 5 times 5 is 5 to the 3rd. So that's how we get 1 over 125. So 5 to the negative 3rd meters is equal to 1 and 125ths meters. So here, let's do some practice on your own together, okay? 4 to the negative 3rd power. I would immediately say, well, I know it's 1 over something because it's a negative power. 4 to the 3rd because I'm going to take out the exponent, the negative part of the exponent, which gives me 1 over 4 times 4 times 4, because 4 to the 3rd is multiplying 4 out 3 times. 4 times 4 is 16. 16 times 4 is 64. So therefore, 4 to the negative 3rd is equal to 1 over 64. Continuing the quiet. So 7 to the 0 power is what? 7 to the 0 power
It's 1.
is 1. Because any
Negative.
blank raised to the 0 power is 1. Let me tell you what fills in that blank there so you can get credit for it.
Exponent.
Oh, duh. Any non-zero number. What is a non-zero number? It's a number that's not 0. Okay, here's a tricky one. So, these have stars next to them. Negative 5 to the negative 4th power. We have 2 negatives. Well, immediately, you ready? Here's my base. Because I see a negative power, I immediately am going to say 1 over. What was my original base?
5.
Negative 5. negative 5 to the 4th power, because all I'm removing, I'm not taking both the negatives away, I'm only taking the negative away on the exponent. So I took the whole same thing, except I got rid of the negative part of the exponent. You see where I did there? Let me finish this last one. That means negative 5 times negative 5 times negative 5 times negative 5. 5 times 5, negative 5 times negative 5 is positive 25. Over here, another positive 25. Positive 25 times positive 25 is 625. So 1 over 625. The last one you can try to do on your own. That's it. And then there's some to practice on your own to see if you get them right. That is the end of the presentation station. After this, when you come back, you can go to learning station, word problem station, or independent workstation.